What if the key to humanity's survival lies not on Earth, but among the stars? Picture this, a future where we're no longer bound by the limits of our planet, where entire civilizations thrive on distant worlds, and where the mysteries of the universe are no longer out of reach. This isn't science fiction, it's the future we're building right now. Welcome to a journey through 30 mind-blowing concepts in space exploration that could redefine what it means to be human. From interstellar travel to megastructures harnessing the power of stars, these ideas aren't just dreams, they're blueprints for a future that's closer than you think. By the end of this video, you'll see how these groundbreaking concepts could shape humanity's destiny, pushing us beyond the boundaries of Earth and into the vast, uncharted cosmos. So buckle up, because the future of space exploration is about to blow your mind. Now, let's take a leap into the stars and explore the first concept on our list, interstellar travel. Imagine a future where humanity isn't confined to our solar system, but ventures out to explore distant stars and potentially habitable worlds. The idea of traveling beyond our cosmic neighborhood is no longer just the stuff of science fiction. It's a real possibility being explored by scientists and engineers today. One of the most exciting theoretical methods for interstellar travel is the concept of warp drives. Inspired by the idea of bending space-time, warp drives could allow spacecraft to travel faster than the speed of light without breaking the laws of physics. While still in the realm of theory, this concept has sparked incredible interest and research into how we might one day achieve such speeds. Another fascinating approach is the use of solar sails. These ultra-thin, reflective sails harness the power of sunlight or even powerful lasers to propel spacecraft to incredible speeds. Unlike traditional rockets, solar sails don't require fuel, making them a sustainable option for long-distance travel. But interstellar travel isn't without its challenges. The distances between stars are mind-bogglingly vast, and even at the fastest speeds we can currently imagine, reaching the nearest star system would take decades, if not centuries. Then there's the issue of energy. How do we power a spacecraft for such an extended journey? And what about the effects of prolonged space travel on human health? These are just some of the hurdles we'll need to overcome. Yet the potential rewards are staggering. Beyond our solar system lie thousands of exoplanets, some of which may be habitable. Discovering a world with the right conditions for life could revolutionize our understanding of the universe and our place within it. Interstellar travel isn't just about exploration, it's about survival, expansion, and the endless pursuit of knowledge. As we continue to push the boundaries of what's possible, the dream of reaching the stars becomes a little more tangible with each passing year. And with that, let's move on to the next groundbreaking concept that could change the way we think about space exploration. Now, let's shift our gaze from the stars to something a little closer to home, yet equally revolutionary. Imagine a towering structure anchored to the Earth and stretching tens of thousands of kilometers into space. This isn't science fiction. It's the concept of space elevators, a groundbreaking idea that could completely transform how we access orbit. Instead of relying on traditional rockets, which are expensive and resource-intensive, a space elevator would use a tether, essentially a super-strong cable, anchored to the Earth's surface and extending into space. At the top of this tether would be a counterweight, keeping the entire structure stable as it rotates with the Earth. The idea is simple yet ingenious. Climbers or robotic vehicles would ascend the tether, carrying cargo, satellites, or even people into orbit. But here's the catch: building such a structure requires materials that are incredibly strong yet lightweight. Enter carbon nanotubes, a material with the potential to make space elevators a reality. These tiny, cylindrical structures are stronger than steel and lighter than aluminum, making them ideal for constructing the tether. However, producing carbon nanotubes at the scale needed for a space elevator is still a significant challenge. If we can overcome this hurdle, the benefits would be enormous. space elevators could drastically reduce the cost of launching materials into orbit, making space travel more accessible and sustainable. Imagine a future where building satellites, space stations, or even interplanetary spacecraft becomes as routine as constructing skyscrapers. The implications for industries like telecommunications, scientific research, and space tourism are staggering. And let's not forget the environmental impact. Space elevators could significantly reduce the carbon footprint of space travel by eliminating the need for rocket fuel. While the concept is still in its early stages, the potential is undeniable. Space elevators could be the key to unlocking a new era of space exploration, one where the stars are no longer out of reach. With that in mind, let's turn our attention to the next concept that could reshape our future among the stars. Now, let's journey from the towering heights of space elevators to the red sands of Mars, where humanity's next great challenge awaits. Terraforming Mars, the idea of transforming this barren, cold planet into a habitable world, has long captured the imagination of scientists and dreamers alike. But how could we possibly turn a planet with a thin atmosphere, freezing temperatures, and no liquid water into a place where humans could thrive? The answer lies in a combination of bold science and futuristic technology. One of the most discussed methods involves releasing greenhouse gases into Mars' atmosphere. By doing this, we could trap heat and gradually warm the planet, potentially melting the ice caps and releasing water vapor. This process, known as planetary engineering, could create a thicker atmosphere and raise temperatures to levels where liquid water could exist. But warming Mars is only part of the puzzle. The planet's lack of a magnetic field means it's constantly bombarded by harmful solar radiation, making the surface inhospitable to life as we know it. To address this, scientists have proposed creating artificial magnetic fields. These could be generated using massive satellites or even by placing superconducting loops around the planet, shielding it from radiation and creating a safer environment for future colonists. However, the idea of terraforming Mars isn't without its controversies. Altering an entire planet raises profound ethical questions. Should we have the right to change another world, even if it's uninhabited? What if Mars harbors microbial life that we haven't yet discovered? These questions remind us that while the technology to terraform Mars may one day exist, the decision to do so will require careful consideration of both scientific and moral implications. Despite these challenges, the vision of a green, thriving Mars remains a powerful symbol of humanity's potential to reshape the cosmos. It's a reminder that our future among the stars isn't just about exploration, it's about creation. With that in mind, let's turn our attention to another awe-inspiring concept that could redefine our place in the universe. Now, let's shift our gaze from the red plains of Mars to the stars themselves, where an even grander vision of human ingenuity awaits. Imagine a structure so vast, so ambitious, that it could encircle an entire star, capturing its energy to power civilizations across the galaxy. This is the concept of a Dyson sphere, a megastructure designed to harness the immense energy output of a star. Proposed by physicist Freeman Dyson in the 1960s, the idea revolves around creating a shell or swarm of orbiting structures around a star, collecting its energy to meet the needs of an advanced civilization. The potential is staggering. A single Dyson sphere could provide virtually unlimited energy, far surpassing anything we currently generate on Earth. This energy could power everything from interstellar travel to massive computational networks, enabling humanity to reach new heights of technological and societal advancement. But building such a structure is no small feat. The sheer scale of a Dyson sphere is almost unimaginable. It would require materials far beyond what Earth can provide, possibly harvested from entire planets or asteroids. The engineering challenges are equally daunting. Constructing a stable, self-sustaining structure around a star would demand technologies we can barely conceive of today, from advanced robotics to self-replicating machines capable of working in the harsh environment of space. And then there's the question of how to transmit the captured energy back to where it's needed. Some proposals suggest using microwave or laser beams to send energy across vast distances, but this introduces its own set of technical and safety challenges. Despite these hurdles, the concept of a Dyson sphere remains a tantalizing glimpse into humanity's potential future. It's a reminder that our ambitions in space aren't just about survival or exploration, they're about harnessing the very forces of the universe to propel us forward. As we ponder the possibilities, let's turn our attention to another fascinating idea that could redefine our understanding of space and time. Now, let's take a leap into the realm of the truly extraordinary wormholes. These theoretical passages through space-time have captured the imagination of scientists and storytellers alike, offering the tantalizing possibility of shortcuts across the universe. Imagine being able to travel from one point in space to another, not by traversing the vast distances in between, but by stepping through a cosmic tunnel that bends the very fabric of reality. This is the essence of a wormhole, a concept rooted in the equations of general relativity. First proposed by physicists Albert Einstein and Nathan Rosen in the 1930s, wormholes are often visualized as bridges connecting two distant points in spacetime, effectively creating a shortcut that could make interstellar travel feasible. In science fiction, wormholes have become a staple, appearing in everything from blockbuster movies to beloved novels as gateways to other galaxies or even alternate dimensions. But what about the science behind them? According to current theories, wormholes could exist as solutions to Einstein's equations, but they would require exotic matter with negative energy to remain stable and traversable. This exotic matter would counteract the immense gravitational forces that would otherwise collapse the wormhole instantly. The challenges don't end there. Even if we could find or create such matter, the energy requirements and technological hurdles to construct and maintain a wormhole are beyond anything humanity has ever attempted. Some scientists speculate that wormholes might exist naturally on a microscopic scale, woven into the quantum fabric of spacetime, but scaling them up to a size usable by humans is a whole different story. Despite these challenges, the idea of wormholes continues to inspire both scientific inquiry and creative storytelling. They represent not just a potential method of travel, but a profound reimagining of how we understand space and time. Could wormholes ever become a reality? For now, they remain a fascinating theoretical possibility, a reminder that the universe is far stranger and more wondrous than we can currently comprehend. As we ponder the mysteries of space-time, let's turn our attention to another groundbreaking concept that could revolutionize how we harness energy from the cosmos. Now, shifting our gaze from the mysteries of space-time to the practicalities of energy, let's explore the concept of space-based solar power. Imagine a future where the sun's energy is harnessed not just on Earth, but directly from space, where sunlight is constant and unobstructed by clouds, atmosphere, or the cycle of day and night. This is the promise of space-based solar power, a revolutionary idea that could transform how we generate and distribute energy. The concept involves placing massive solar panels in orbit around Earth, where they can collect sunlight 24 hours a day, 7 days a week. These panels would then convert the solar energy into microwaves or laser beams, which could be transmitted wirelessly to receiving stations on Earth. Once received, the energy would be converted back into electricity and fed into the power grid, providing a clean, renewable source of energy on a global scale. One of the most significant advantages of space-based solar power is its ability to provide uninterrupted energy. Unlike ground-based solar farms, which are limited by weather conditions and the rotation of the Earth, space-based systems operate in an environment where sunlight is always available. This could make it a game-changer for regions that struggle with energy shortages or rely heavily on fossil fuels. Additionally, space-based solar power could help reduce greenhouse gas emissions, offering a sustainable solution to the growing demand for energy as the world transitions away from carbon-intensive sources. However, the challenges of making this vision a reality are immense. One of the biggest hurdles is the transmission of energy from space to Earth. While microwaves and lasers are the leading candidates for wireless energy transfer, both methods come with technical and safety concerns. Microwaves, for example, require large receiving antennas and must be carefully controlled to avoid interference with communication systems or harm to living organisms. Lasers, on the other hand, are more precise but can be affected by atmospheric conditions such as clouds or dust, which could disrupt the energy beam. Another major challenge is the infrastructure required to build, launch, and maintain space-based solar power systems. Constructing solar panels large enough to generate significant amounts of energy would require advanced materials and manufacturing techniques, as well as cost-effective methods for launching them into orbit. Maintenance would also be a concern, as any damage or malfunction in space would be difficult and expensive to repair. Despite these obstacles, the potential benefits of space-based solar power are too significant to ignore. As technology advances and the cost of space travel decreases, this concept could move from science fiction to reality, offering a clean, reliable, and virtually limitless source of energy for our planet. As we consider the possibilities of harnessing the sun's power from space, let's turn our attention to another groundbreaking idea that could reshape our relationship with the cosmos: asteroid mining. Now let's venture into the realm of asteroid mining, a concept that could unlock untold riches and reshape the future of both Earth and space exploration. Imagine a world where the vast, rocky bodies drifting through our solar system are not just celestial curiosities, but treasure troves of precious metals and rare resources. This is the promise of asteroid mining, an idea that could revolutionize industries on Earth and provide the building blocks for humanity's expansion into the cosmos. Asteroids are rich in valuable materials like platinum, gold, iron, nickel, and even water. These resources are not only essential for modern technology and manufacturing, but could also play a critical role in supporting long-term space missions. For example, water extracted from asteroids could be split into hydrogen and oxygen, providing both fuel for spacecraft and breathable air for astronauts. This would reduce the need to launch heavy supplies from Earth, making space exploration more sustainable and cost-effective. The potential economic impact of asteroid mining is staggering. Rare metals like platinum, which are in high demand for electronics, medical devices, and renewable energy technologies, are relatively scarce on Earth. Mining asteroids could provide a virtually limitless supply of these materials, driving down costs and spurring innovation across multiple industries. Moreover, the ability to harvest resources in space could reduce the environmental toll of mining on Earth, where extraction processes often lead to deforestation, pollution, and habitat destruction. However, the challenges of asteroid mining are as vast as the opportunities. First, there's the issue of locating and reaching these distant objects. While some asteroids pass relatively close to Earth, others are millions of miles away, requiring advanced propulsion systems and precise navigation to reach them. Once an asteroid is reached, the process of extracting resources in the harsh, zero-gravity environment of space presents its own set of technical hurdles. Specialized equipment would need to be developed to drill, crush, and process asteroid material, all while operating in the vacuum of space. Another challenge is the legal and ethical framework surrounding asteroid mining. Who owns the resources extracted from these celestial bodies? Current international space treaties are vague on this issue, leaving room for debate and potential conflict. Establishing clear guidelines for resource ownership and exploitation will be crucial to ensuring that asteroid mining benefits all of humanity, rather than just a few nations or corporations. Despite these challenges, the potential rewards of asteroid mining are too significant to ignore. As technology advances and the cost of space travel continues to decrease, this once fanciful idea is becoming increasingly feasible. Companies and governments around the world are already investing in research and development, with the goal of making asteroid mining a reality within the next few decades. As we look to the stars for the resources that could power our future, let's turn our attention to another groundbreaking concept that could redefine life in space: artificial gravity. Now, let's shift our focus to a concept that could make life in space feel a little more like home: artificial gravity. Imagine floating effortlessly in zero gravity, a sensation that might seem thrilling at first, but over time it poses serious challenges for human health. Prolonged exposure to weightlessness can lead to muscle atrophy, bone density loss, and even vision problems. This is where artificial gravity comes in, offering a potential solution to keep astronauts healthy during long-term missions. One of the most promising methods for creating artificial gravity is through rotating spacecraft. Picture a massive cylindrical space station spinning slowly in orbit. The centrifugal force generated by this rotation would push objects and people outward, mimicking the effects of gravity. The faster the rotation, the stronger the simulated gravity. This concept, often seen in science fiction, is grounded in real physics and could be the key to making space habitats more livable. But why is gravity so important for human health? On Earth, our bodies are constantly working against gravity, which helps maintain muscle mass and bone strength. In space, without this resistance, muscles weaken and bones lose density at an alarming rate. Artificial gravity could counteract these effects, allowing astronauts to stay healthier for longer periods. It could also make everyday tasks like eating, drinking, and even sleeping much easier and more comfortable. Designing a rotating spacecraft, however, is no simple feat. The structure would need to be large enough to minimize the disorienting effects of the Coriolis force, which can cause dizziness and nausea if the rotation is too fast or the radius too small. Engineers would also need to ensure the station's stability and balance, as any irregularities could disrupt the artificial gravity or even damage the spacecraft. Despite these challenges, the potential benefits make it a compelling area of research. Beyond rotating spacecraft, other methods of creating artificial gravity are also being explored. Some proposals suggest using linear acceleration, where a spacecraft continuously accelerates to create a gravitational effect. Others imagine harnessing magnetic fields or even advanced materials to simulate gravity. While these ideas are still in their early stages, they highlight the creativity and innovation driving this field. As we continue to push the boundaries of space exploration, artificial gravity could play a crucial role in ensuring the well-being of astronauts and the success of long-term missions. It's a reminder that even in the vast emptiness of space, we can find ways to bring a little piece of Earth with us. Next, let's explore another fascinating concept that could redefine how we live beyond our planet's space habitats. Now, let's take a step further into the future and explore the concept of space habitats: self-sustaining environments designed to support human life beyond Earth. These habitats could be the key to establishing permanent human settlements in space, offering a safe and comfortable place to live, work, and thrive. One of the most iconic designs for such habitats is the O'Neill cylinder, a massive structure that could house thousands of people while mimicking the conditions of Earth. An O'Neill cylinder is essentially a giant rotating tube, similar to the rotating spacecraft we discussed earlier, but on a much larger scale. Picture a cylinder several miles long and wide, spinning to create artificial gravity along its inner surface. The interior would be divided into land areas, complete with soil, plants, and even bodies of water, creating a miniature Earth-like environment. Sunlight would be reflected into the cylinder through mirrors, simulating a natural day-night cycle. It's a vision that blends engineering brilliance with the beauty of nature, offering a glimpse of what life in space could look like. But building such a habitat isn't just about creating space, it's about sustaining life. These habitats would need advanced life support systems to recycle air, water, and waste, ensuring a closed-loop ecosystem. Plants would play a crucial role, not only providing oxygen but also serving as a food source. Imagine vast green spaces within the cylinder, where crops grow under carefully controlled conditions, free from pests and unpredictable weather. It's a system that would require precision and innovation, but the rewards could be immense. The potential for large-scale human settlements in space is staggering. O'Neill cylinders and similar habitats could serve as stepping stones for colonizing other planets or even traveling to distant star systems. They could also provide a solution to overpopulation and resource scarcity on Earth, offering new frontiers for exploration and development. Imagine entire cities floating in space, with schools, hospitals, and industries thriving in a self-sufficient environment. It's a future that feels both ambitious and achievable, given the rapid advancements in space technology. Of course, the challenges are significant. Constructing such massive structures in space would require unprecedented levels of engineering and resources. Transporting materials from Earth or mining asteroids for construction would be essential steps. Additionally, maintaining the delicate balance of life support systems over long periods would demand constant monitoring and innovation. Yet, the vision of space habitats represents a bold step toward humanity's future in the cosmos. As we look ahead, space habitats like O'Neill cylinders remind us that the boundaries of human ingenuity are limitless. They offer not just a place to live, but a new way of life, one that could redefine our relationship with the universe. Next, we'll dive into another groundbreaking concept that could revolutionize how we communicate across the vast distances of space: quantum communication. Now, shifting our focus to the realm of cutting-edge technology, let's explore the fascinating concept of quantum communication in space. Imagine a future where sending messages across the cosmos isn't just faster, but also completely secure, thanks to the principles of quantum mechanics. This revolutionary approach to data transmission could redefine how we communicate in space, opening up new possibilities for interstellar exploration and collaboration. At its core, quantum communication relies on the unique properties of quantum particles, such as photons, to transmit information. Unlike traditional methods which use radio waves or lasers, quantum communication leverages a phenomenon called quantum entanglement. This occurs when two particles become linked so that the state of one instantly influences the other, no matter how far apart they are. This means that information can be shared between 2 points in space almost instantaneously, without the delays caused by the vast distances involved. One of the most exciting applications of quantum communication is its potential for ultra-secure data transmission. Because quantum particles are incredibly sensitive to interference, any attempt to intercept or tamper with the information would immediately alter the particle's states, alerting both sender and receiver to the breach. This makes quantum communication virtually unhackable, a game-changer for transmitting sensitive data across the cosmos. Imagine sending mission-critical information between Earth and a distant colony on Mars, or even to a spacecraft exploring the outer reaches of our solar system, with absolute confidence in its security. But the benefits don't stop there. Quantum communication could also play a crucial role in interstellar exploration. As we venture further into the universe, the time it takes for signals to travel between Earth and distant probes or colonies becomes a significant challenge. With quantum communication, we could establish real-time links with spacecraft exploring other star systems, enabling faster decision-making and more efficient mission control. This could dramatically enhance our ability to explore and understand the universe, bringing distant worlds within reach like never before. Of course, the technology is still in its early stages, and there are significant hurdles to overcome. Creating and maintaining quantum entanglement over vast distances is no small feat, and the equipment required is highly sensitive and complex. However, researchers are making rapid progress, and the potential rewards are too great to ignore. Quantum communication could not only transform how we explore space, but also pave the way for a new era of secure, instantaneous communication across the cosmos. As we continue to push the boundaries of what's possible, quantum communication stands as a testament to humanity's ingenuity and determination. It's a concept that bridges the gap between science fiction and reality, offering a glimpse of a future where the stars are no longer out of reach. Next, we'll delve into another groundbreaking idea that could make long-duration space travel a reality: cryosleep. Now, let's turn our attention to a concept that feels like it's straight out of a sci-fi movie but could one day become a reality: cryosleep for space travel. Imagine embarking on a journey to a distant star system, not by spending decades awake in a spacecraft, but by entering a state of suspended animation where time seems to stand still. This idea, often seen in films and books, is being seriously explored as a way to make interstellar travel not just possible, but practical. Cryosleep, or suspended animation, involves slowing down the body's metabolic processes to a near halt, effectively putting a person into a deep sleep. This would allow astronauts to endure the long durations required for interstellar travel without aging significantly or consuming large amounts of resources like food, water, and oxygen. The science behind this concept is rooted in the way certain animals, like bears and frogs, naturally enter states of hibernation to survive harsh conditions. By mimicking these natural processes, scientists hope to develop technologies that could safely induce a similar state in humans. One of the key challenges is figuring out how to safely lower the body's temperature without causing damage. Extreme cold can be dangerous, as it can lead to tissue damage or even death. However, researchers are exploring methods like using special chemicals or advanced cooling techniques to gradually reduce the body's temperature and slow down cellular activity. Once in this state, the body would require minimal energy, allowing astronauts to sleep through the majority of their journey. Another critical aspect is the revival process. Waking someone from cryosleep would require carefully controlled procedures to restore normal body functions without causing harm. This includes gradually raising the body's temperature and ensuring that all organs and systems return to full operation. While this sounds complex, advancements in medical technology are bringing us closer to making it a reality. The potential benefits of cryosleep are enormous. For one, it could drastically reduce the psychological and physical challenges of long-duration space travel. Spending years or even decades in the confined space of a spacecraft can take a toll on mental health, but cryosleep could eliminate that issue entirely. Additionally, it would make interstellar missions more feasible by reducing the need for massive amounts of supplies, allowing spacecraft to be smaller, lighter, and more efficient. Of course, there are still significant hurdles to overcome. The technology is in its early stages, and much more research is needed to ensure it's safe and effective for human use. Ethical considerations also come into play, such as the potential risks involved and the long-term effects on the human body. But if successful, cryosleep could revolutionize space travel, making the dream of exploring distant stars a tangible reality. As we continue to push the boundaries of human exploration, cryosleep represents a bold step forward, blending science and imagination in ways that could redefine our place in the universe. Next, we'll explore another innovative idea that could transform how we manufacture goods beyond Earth: space-based manufacturing. Now, let's shift our focus to a concept that could redefine how we produce goods and materials: space-based manufacturing. Imagine a world where some of the most advanced products we use every day are made not on Earth, but in the vast, weightless environment of space. This isn't just a futuristic dream, it's a possibility that scientists and engineers are actively working toward, and the benefits could be game-changing for multiple industries. One of the most significant advantages of manufacturing in space is the unique conditions created by microgravity. On Earth, gravity affects everything from the way materials mix to how they solidify, often leading to imperfections. But in space, the absence of gravity allows for the creation of materials with properties that are simply impossible to achieve on our planet. For example, metals can be mixed more evenly, resulting in stronger, more durable alloys. Crystals can grow larger and more pure, which is particularly valuable for industries like electronics and optics. The pharmaceutical industry stands to gain immensely from space-based manufacturing. In microgravity, scientists can produce drugs with more precise molecular structures, potentially leading to more effective medications with fewer side effects. For instance, protein crystals grown in space have already shown promise in improving treatments for diseases like cancer and Parkinson's. By moving certain aspects of drug production to space, we could unlock breakthroughs that save lives and improve health outcomes worldwide. Electronics is another field that could see revolutionary advancements. The production of semiconductors, which are the backbone of modern technology, often faces challenges due to gravity-induced defects. In space, these defects could be minimized, leading to faster, more efficient microchips. This could accelerate the development of everything from smartphones to supercomputers, pushing the boundaries of what technology can achieve. Beyond these industries, space-based manufacturing could also benefit fields like energy and construction. For example, the production of ultra-lightweight materials in space could lead to more efficient solar panels or stronger, lighter building materials. Even the art world could see new possibilities, with unique materials and textures created in microgravity, inspiring entirely new forms of creative expression. Of course, there are challenges to overcome. The cost of launching materials and equipment into space remains high, and the logistics of operating manufacturing facilities in orbit are complex. However, as space travel becomes more affordable and reusable rocket technology advances, these barriers are gradually being lowered. Companies and governments are already investing in research and pilot projects, signaling a growing belief in the potential of space-based manufacturing. As we look to the future, the idea of producing goods in space opens up a world of possibilities. It's not just about making things better, it's about making things we've never even imagined before. Next, we'll explore another groundbreaking concept, the search for and potential colonization of exoplanets, and what it could mean for the future of humanity. Now, let's journey beyond our solar system to explore one of the most ambitious goals in space exploration, the search for and potential colonization of exoplanets. Imagine a future where humanity isn't confined to Earth but spreads across the stars, establishing new homes on distant worlds. This idea, once the realm of science fiction, is now a serious topic of scientific research and technological innovation. The first step in this grand endeavor is finding exoplanets, planets that orbit stars outside our solar system that could support life. Scientists look for planets within the habitable zone, the region around a star where temperatures are just right for liquid water to exist. Water is essential for life as we know it, so finding planets with this potential is a top priority. Telescopes like the James Webb Space Telescope are already scanning the skies, identifying promising candidates that could one day become humanity's new frontiers. But finding a habitable exoplanet is only the beginning. The challenges of reaching these distant worlds are immense. Even the closest exoplanets are light years away, meaning it would take thousands of years to reach them with current technology. This raises questions about how we could make such a journey feasible. Concepts like cryosleep, where astronauts are placed in a state of suspended animation, or generation ships, where multiple generations live and die during the voyage, are being explored as potential solutions. Advances in propulsion technology, such as nuclear or antimatter engines, could also drastically reduce travel times, but these remain in the realm of theory for now. Once we reach an exoplanet, the challenges continue. Colonizing a new world would require overcoming harsh environments, from extreme temperatures to toxic atmospheres. Terraforming, the process of altering a planet's environment to make it Earth-like, could be a solution, but it's a monumental task that would take centuries, if not millennia. Even then, the ethical implications of altering another planet's ecosystem raise important questions. Should we have the right to change an entire world, even if it's uninhabited? What if life already exists there, even in microbial form? These are dilemmas that humanity will need to address as we venture further into the cosmos. Despite these challenges, the potential rewards of exoplanet colonization are immense. Establishing colonies on other planets could ensure the survival of humanity in the face of existential threats, such as asteroid impacts or climate change. It could also open up new opportunities for scientific discovery, allowing us to study alien ecosystems and expand our understanding of life in the universe. As we look to the stars, the dream of exoplanet colonization reminds us of humanity's boundless curiosity and drive to explore. It's a vision that pushes the limits of what we believe is possible, challenging us to think beyond our world and imagine a future among the stars. Next, we'll dive into another fascinating concept, the manipulation of space-time and how it could revolutionize the way we travel through the cosmos. Now, let's shift our focus to a concept that sounds like it's straight out of science fiction, but is rooted in real scientific theory: the manipulation of space-time. Imagine bending the very fabric of the universe to travel vast distances in the blink of an eye, or experiencing time in a completely different way. This idea, while still theoretical, could revolutionize how we explore the cosmos. At the heart of space-time manipulation is Einstein's theory of general relativity, which describes how massive objects like stars and planets warp the space and time around them. Think of space-time as a stretchy fabric. When you place a heavy object on it, like a bowling ball, it creates a dent. Smaller objects like marbles will roll toward the dent, just as planets orbit a star. This warping effect is what we call gravity. But what if we could control this warping? What if we could create our own dents in space-time to move faster or even slow down time? One of the most intriguing possibilities is the concept of wormholes, which we touched on earlier. These hypothetical tunnels through space-time could act as shortcuts, allowing us to travel between two distant points almost instantly. While wormholes remain purely theoretical, they're a fascinating example of how manipulating space-time could make interstellar travel feasible. Another idea is the Alcubierre drive, a theoretical concept that involves creating a warp bubble around a spacecraft. This bubble would compress space in front of the ship and expand it behind, effectively allowing the ship to travel faster than the speed of light without breaking the laws of physics. But space-time manipulation isn't just about speed. It also opens the door to time dilation, a phenomenon where time passes differently depending on your speed or proximity to a massive object. For example, astronauts on the International Space Station experience time slightly slower than people on Earth because they're moving faster and are farther from Earth's gravity. On a much larger scale, traveling near a black hole could slow time dramatically. This means a person near a black hole might age only a few years while decades pass for everyone else. While this sounds like the plot of a sci-fi movie, it's grounded in real physics. The implications of space-time manipulation for space exploration are staggering. If we could harness these principles, we could drastically reduce travel times to distant stars and galaxies, making interstellar colonization a realistic goal. It could also allow us to study the universe in ways we can't even imagine today, from observing the birth of stars to exploring the edges of known space. Of course, the challenges are immense. the energy required to manipulate space-time is beyond anything we can currently produce, and the technology to do so remains purely speculative. But as our understanding of physics grows, so does the possibility that one day we might unlock the secrets of space-time and take humanity's exploration of the cosmos to entirely new heights. As we ponder these mind-bending ideas, let's turn our attention to another groundbreaking concept: self-replicating spacecraft and how they could enable large-scale exploration and resource utilization across the universe. Now let's dive into a concept that could redefine the scale of space exploration: self-replicating spacecraft. Imagine a fleet of robotic explorers that not only travel to distant worlds but also build copies of themselves using materials they find along the way. This idea, while still in its early stages, could revolutionize how we explore and utilize the vast resources of the universe. At its core, the concept of self-replicating spacecraft is inspired by nature. Just as living organisms reproduce and adapt, these spacecraft would be designed to harvest raw materials from asteroids, moons, or even planets to construct new versions of themselves. Think of it as a cosmic assembly line where each new spacecraft continues the mission, expanding humanity's reach exponentially without the need for constant resupply from Earth. One of the biggest advantages of self-replicating spacecraft is their potential to overcome the limitations of distance and time. Traditional missions require enormous amounts of fuel and resources, making long-term exploration costly and logistically challenging. But if a spacecraft can mine metals, extract water, and manufacture components in space, it could sustain itself indefinitely. This would allow us to explore far beyond our solar system, reaching distant star systems and even other galaxies over time. Another exciting possibility is the utilization of space resources on a massive scale. Self-replicating spacecraft could mine asteroids for rare metals like platinum or gold, which are scarce on Earth but abundant in space. They could also harvest water ice from moons or comets, turning it into fuel or life support for future missions. This would not only support exploration but also create a new space-based economy, reducing our reliance on Earth's dwindling resources. Of course, the challenges are significant. Designing a spacecraft capable of autonomous replication requires breakthroughs in robotics, artificial intelligence, and materials science. We'd need machines that can identify, extract, and process raw materials with precision, as well as systems that can assemble complex components in the harsh environment of space. And then there's the question of control, ensuring these self-replicating systems remain aligned with human goals and don't spiral out of control. Despite these hurdles, the potential rewards are immense. Self-replicating spacecraft could enable us to build vast networks of probes, satellites, and habitats across the cosmos, creating a true interstellar infrastructure. They could pave the way for large-scale colonization, turning distant worlds into new homes for humanity. And they could help us answer some of the biggest questions about the universe, from the origins of life to the existence of other civilizations. As we look to the future, the idea of self-replicating spacecraft reminds us that the boundaries of exploration are limited only by our imagination and ingenuity. With each step forward, we move closer to a future where humanity's presence extends far beyond our pale blue dot. And with that, let's turn our attention to another incredible tool in our cosmic toolkit: space-based telescopes and their role in uncovering the mysteries of the universe. Now, shifting our gaze to the stars, let's explore the incredible world of space-based telescopes. These marvels of engineering have transformed our understanding of the cosmos, allowing us to peer deeper into the universe than ever before. At the forefront of this revolution is the James Webb Space Telescope, a groundbreaking instrument that has already begun to rewrite the textbooks on astronomy. The James Webb Space Telescope, often referred to as Webb, is designed to observe the universe in infrared light, revealing details that were previously hidden from view. Unlike its predecessor, the Hubble Space Telescope, which primarily captures visible light, Webb can see through cosmic dust clouds and detect the faint glow of the earliest galaxies. This capability has allowed scientists to study the formation of the first stars and galaxies, shedding light on the origins of the universe itself. But Webb is just the beginning. Future space telescopes promise to push the boundaries even further. Concepts like the Large Ultraviolet Optical Infrared Surveyor, or LUVOIR, aim to provide even sharper images and a wider field of view. These next-generation telescopes could potentially detect signs of life on distant exoplanets by analyzing their atmospheres for biomarkers like oxygen or methane. Imagine the implications of discovering a world with conditions similar to Earth. It would fundamentally change how we see our place in the universe. Another exciting concept is the Habitable Exoplanet Imaging Mission, or HAB-X, which focuses on directly imaging Earth-like planets orbiting nearby stars. By blocking out the blinding light of their host stars, HAB-X could reveal the faint glow of these distant worlds, allowing us to study their surfaces and atmospheres in unprecedented detail. This could bring us one step closer to answering the age-old question: are we alone in the universe? Space-based telescopes also play a crucial role in studying phenomena that are invisible from Earth, such as black holes and neutron stars. Instruments like the Chandra X-ray Observatory have provided stunning insights into these extreme environments, capturing the high-energy radiation they emit. Future telescopes could take this even further, offering new perspectives on the most violent and energetic events in the cosmos. Of course, building and launching these advanced telescopes is no small feat. They require cutting-edge technology, precise engineering, and significant investment, but the rewards are immeasurable. Each new telescope brings us closer to unraveling the mysteries of the universe, from the nature of dark matter and dark energy to the ultimate fate of the cosmos. As we continue to develop these incredible tools, one thing is clear: space-based telescopes are not just instruments of science, they are windows into the unknown. They remind us of the vastness of the universe and the endless possibilities that lie beyond our own world. And with that, let's turn our attention to another pressing challenge in space exploration: the growing problem of space debris and the technologies being developed to clean it up. Now, as we look beyond the stars and into the challenges closer to home, let's tackle a pressing issue that threatens the future of space exploration: space debris. Over the decades, humanity's ventures into space have left behind a trail of discarded rocket stages, defunct satellites, and countless fragments of debris. This growing cloud of space junk now orbits Earth at incredible speeds, posing a significant risk to active satellites, the International Space Station, and future missions. The problem of space debris is more serious than it might seem. Even a tiny piece of debris traveling at thousands of miles per hour can cause catastrophic damage to spacecraft. Collisions with debris can create even more fragments, leading to a dangerous chain reaction known as the Kessler syndrome. If left unchecked, this could render entire orbits unusable, effectively trapping us on Earth and halting further exploration. To combat this, scientists and engineers are developing innovative technologies to clean up space debris. One promising approach involves using robotic arms or nets to capture and deorbit large pieces of debris. For example, missions like the European Space Agency's Clear Space One aim to demonstrate this technology by safely removing defunct satellites from orbit. Another method being explored is the use of lasers to nudge smaller debris into lower orbits, where it will burn up upon re-entering Earth's atmosphere. But cleanup efforts alone aren't enough. Preventing new debris is equally critical. Many space agencies and private companies are now designing satellites with end-of-life plans, such as built-in propulsion systems to deorbit them once their missions are complete. Additionally, international guidelines are being developed to encourage responsible behavior in space, ensuring that future missions minimize their impact on the orbital environment. Maintaining a safe and sustainable orbital environment is essential not just for current missions, but for the future of space exploration. Without clean orbits, ambitious projects like lunar bases, Mars colonies, and interstellar probes could face insurmountable challenges. By addressing the issue of space debris now, we're not only protecting our current infrastructure, but also paving the way for humanity's next giant leap into the cosmos. With this critical challenge in mind, let's turn our attention to another exciting frontier: the plans for establishing permanent bases on the Moon and how they could serve as a stepping stone for deeper space exploration. Now, as we shift our gaze from the challenges of Earth's orbit to the possibilities waiting on our celestial neighbor, let's explore the exciting plans for establishing permanent bases on the Moon. The Moon has long been a symbol of human ambition, and today, it stands as a critical stepping stone for deeper space exploration. Establishing a lunar base isn't just about planting a flag, it's about creating a sustainable presence that can support scientific discovery, technological innovation, and even future missions to Mars and beyond. One of the most compelling reasons for building a lunar base is the opportunity to test and refine technologies that will be essential for Mars colonization. The Moon's environment, with its lower gravity and lack of atmosphere, provides a unique testing ground for systems like life support, habitat construction, and resource utilization. For example, NASA's Artemis program aims to return humans to the Moon by the mid-2020s with the goal of establishing a sustainable presence. This lunar base will serve as a proving ground for technologies that could one day support human life on Mars, such as advanced water extraction systems and 3D printed habitats made from lunar soil. But the Moon isn't just a testing ground, it's also a treasure trove of resources. Lunar regolith, the layer of loose material covering the Moon's surface, contains valuable elements like oxygen, silicon, and metals such as aluminum and titanium. These resources could be used to build infrastructure on the Moon itself, reducing the need to transport materials from Earth. Additionally, scientists believe that water ice trapped in permanently shadowed craters near the Moon's poles could be harvested and converted into drinking water, oxygen for breathing, and even rocket fuel. This in situ resource utilization, or ISRU, could revolutionize space exploration by making missions more self-sufficient and cost-effective. Beyond its practical benefits, a lunar base would also open up new frontiers for scientific research. The Moon's surface offers a pristine environment for studying the history of our solar system, free from the weathering and erosion that affect Earth. Astronomers could also take advantage of the Moon's lack of atmosphere to build powerful telescopes, providing unprecedented views of the cosmos. And let's not forget the potential for international collaboration. Lunar bases could become hubs for global cooperation, bringing together nations to work toward a shared vision of space exploration. As we look to the future, the Moon represents more than just a destination, it's a gateway. By establishing a permanent presence there, we're not only advancing our understanding of the universe, but also laying the groundwork for humanity's next great adventure, the journey to Mars and beyond. With this vision in mind, let's turn our attention to another exciting development in space exploration: the emerging industry of space tourism and how it's making the cosmos accessible to more people than ever before. Now, as we transition from the Moon's potential as a launchpad for deeper space exploration, let's take a closer look at an industry that's bringing the cosmos closer to everyday people: space tourism. Once the stuff of science fiction, space tourism is rapidly becoming a reality, thanks to advancements in technology and the vision of pioneering companies. This emerging industry isn't just about offering a few minutes of weightlessness, it's about opening up the final frontier to a broader audience, making space travel an experience that more people can dream of and eventually achieve. At the forefront of this movement are companies like SpaceX, Blue Origin, and Virgin Galactic. Each of these players is taking a unique approach to space tourism. SpaceX, for instance, has already sent private citizens into orbit aboard its Crew Dragon spacecraft, offering multi-day trips that include breathtaking views of Earth and the chance to experience life in microgravity. Blue Origin, on the other hand, focuses on suborbital flights, providing passengers with a brief but unforgettable journey to the edge of space, where they can see the curvature of the Earth and the blackness of space. Virgin Galactic is also making strides with its spaceplane, designed to carry tourists on suborbital flights, offering a taste of space travel with a focus on comfort and luxury. But what is it actually like to travel to space? For those lucky enough to experience it, the journey begins long before liftoff. Passengers undergo training to prepare for the physical and psychological demands of spaceflight, from handling microgravity to understanding the safety protocols. Once in space, the experience is nothing short of transformative. Imagine floating weightlessly, gazing out at the Earth below, a vibrant blue sphere against the infinite black of space. It's a perspective that has been described as life-changing, offering a profound sense of connection to our planet and the universe beyond. The potential for space tourism goes far beyond these initial experiences. As the industry matures, the cost of space travel is expected to decrease, making it accessible to more people. Companies are already exploring ways to expand their offerings, from orbital hotels to lunar flybys. Imagine a future where spending a week in a space hotel or taking a trip around the moon becomes as common as a vacation to a tropical island. This democratization of space travel could inspire a new generation of explorers, scientists, and dreamers, fostering a deeper appreciation for the wonders of the cosmos. Of course, challenges remain. Safety, affordability, and environmental impact are all critical factors that need to be addressed as the industry grows. But the progress made so far is a testament to human ingenuity and our enduring desire to explore. Space tourism represents a bold new chapter in our relationship with space, one where the stars are no longer out of reach for the average person. As we look ahead, the possibilities are as vast as space itself, and the journey is just beginning. With that in mind, let's turn our attention to another groundbreaking concept: the idea of creating an interplanetary internet network that could connect humanity across the solar system. Now, shifting our gaze from the thrill of space tourism to the practicalities of connecting humanity across the cosmos, let's explore the fascinating concept of an interplanetary internet. Imagine a network that doesn't just link devices on Earth but extends its reach to Mars, the Moon, and beyond. This isn't just about sending emails or streaming videos. It's about creating a communication infrastructure that supports future colonies, scientific missions, and even everyday life for those living off-world. The idea of an interplanetary internet might sound like something straight out of a sci-fi movie, but it's a very real challenge that scientists and engineers are already tackling. The biggest hurdle, distance. On Earth, data travels at the speed of light, which is incredibly fast, about 300,000 kilometers per second. But when you're dealing with planets millions of kilometers apart, even light-speed communication isn't instantaneous. For example, a signal sent from Earth to Mars can take anywhere from 4 to 24 minutes to arrive, depending on the planet's positions in their orbits. This delay, known as latency, makes real-time communication impossible and requires entirely new approaches to how we send and receive data. To address this, researchers are developing protocols specifically designed for space. One of the most promising is the delay-tolerant networking, or DTN, system. Unlike traditional internet protocols, which assume a constant connection, DTN is built to handle interruptions and delays. It stores data at various points along the transmission path, forwarding it only when a connection becomes available. Think of it like a cosmic relay race, where information is passed from one node to the next until it reaches its destination. This method ensures that critical data, whether it's scientific findings or personal messages, eventually gets through, even if it takes hours or days. Another challenge is the sheer volume of data that future interplanetary missions will generate. High-resolution images, detailed scientific measurements, and even video feeds from rovers or astronauts will require massive amounts of bandwidth. To manage this, scientists are exploring advanced compression techniques and more efficient ways to encode data. They're also looking at using lasers for communication, which can transmit information at much higher speeds than traditional radio waves. Laser-based systems could drastically reduce transmission times, making it easier to send large files across the solar system. But why is an interplanetary internet so important? Beyond the obvious benefits of staying connected, it's essential for the success of long-term missions and colonies. Imagine a Mars colony needing real-time updates from Earth about weather patterns, medical advice, or even just a video call with loved ones. An interplanetary internet would also enable collaboration between scientists on different planets, allowing them to share data and insights instantly, or as instantly as the laws of physics allow. As we look to the future, the development of an interplanetary internet represents a crucial step in humanity's journey to becoming a multi-planetary species. It's not just about technology, it's about building the bridges that will connect us no matter how far apart we are. And with that, let's turn our attention to another innovative concept that could revolutionize life in space: the potential for growing food beyond Earth, a topic that's as vital as it is fascinating. Now, as we venture into the realm of sustaining life beyond Earth, let's explore the groundbreaking concept of space-based agriculture. Picture this: lush green plants thriving in the sterile environment of a space station or a Martian colony, providing fresh food for astronauts and settlers. This isn't just about survival, it's about creating a self-sufficient ecosystem that can support long-term missions and even permanent settlements in space. Growing food in space presents a unique set of challenges, starting with the absence of gravity. On Earth, gravity plays a crucial role in how plants grow, from the way roots anchor into soil to how water and nutrients are distributed. In microgravity, these processes don't work the same way. Water, for instance, doesn't flow downward. It forms floating blobs that can drown plant roots if not managed carefully. To tackle this, scientists have developed innovative farming techniques such as hydroponics and aeroponics. These methods allow plants to grow without soil, using nutrient-rich water or mist instead. In hydroponics, plants are suspended in a solution that delivers nutrients directly to their roots, while aeroponics involves spraying the roots with a fine mist. Both techniques are highly efficient and use less water than traditional farming, making them ideal for space environments. But it's not just about water and nutrients. Light is another critical factor. In space, natural sunlight isn't always available, especially on planets like Mars, where dust storms can block sunlight for weeks. To solve this, researchers are using LED lights that mimic the spectrum of sunlight, optimized for plant growth. These lights can be adjusted to provide the exact wavelengths plants need for photosynthesis, ensuring they grow healthy and strong. Some experiments have even shown that certain plants grow faster and produce higher yields under these controlled conditions compared to traditional farming on Earth. Another challenge is the limited space available for farming. Space stations and future colonies won't have vast fields to cultivate crops, so every square centimeter counts. Vertical farming, where plants are stacked in layers, is one solution being explored. This method maximizes space efficiency and can be adapted to fit the compact environments of spacecraft or habitats. Imagine a wall of leafy greens or a tower of strawberries, all grown in a small, enclosed area. It's not just practical, it's also visually appealing, adding a touch of Earth-like greenery to the sterile surroundings of space. Of course, space-based agriculture isn't just about growing food. It's also about creating a sustainable cycle where waste is recycled into resources. For example, astronauts' waste can be processed into fertilizer, providing nutrients for plants. In turn, the plants produce oxygen and help filter carbon dioxide, contributing to a closed-loop life support system. This kind of synergy is essential for long-term missions where resupply from Earth isn't feasible. The potential benefits of space-based agriculture extend beyond just feeding astronauts. It could also pave the way for large-scale food production on other planets, supporting future colonies and even reducing the strain on Earth's resources. Imagine a future where Martian settlers grow their own wheat, tomatoes, and herbs, creating a taste of home millions of kilometers away. It's a vision that combines science, innovation, and a deep connection to our roots, literally. As we look ahead, the development of space-based agriculture represents a vital step in humanity's journey to becoming a multi-planetary species. It's not just about solving the technical challenges, it's about reimagining how we live and thrive in the cosmos. And with that, let's turn our attention to another fascinating concept that could redefine our relationship with space: the potential for space elevators on the Moon and Mars, where lower gravity opens up entirely new possibilities. Now, shifting our gaze to the Moon and Mars, let's explore how space elevators could take on a whole new dimension in these extraterrestrial environments. While Earth-based space elevators face immense challenges due to our planet's gravity and atmosphere, the Moon and Mars offer unique advantages that could make these structures not only feasible but transformative for future exploration and colonization. On the Moon, the lower gravity, about 1/6 of Earth's, drastically reduces the tension and structural demands on a space elevator. This means the materials needed to build one wouldn't have to be as strong or as advanced as those required for an Earth-based version. Imagine a lunar space elevator anchored to the Moon's surface, extending tens of thousands of kilometers into space. Such a structure could serve as a vital link between the lunar surface and a space station or gateway in lunar orbit. This would make transporting resources, equipment, and even people between the Moon and orbit far more efficient and cost-effective than relying solely on rockets. For instance, mined lunar materials like helium-3, which could be used for future fusion energy, could be transported to orbit with ease, opening up new possibilities for lunar industries. Mars, with its gravity about 1/3 of Earth's, also presents a compelling case for space elevators. While the red planet's thin atmosphere poses fewer challenges than Earth's, its two small moons, Phobos and Deimos, could play a key role in the design of a Martian space elevator. One intriguing idea involves anchoring the elevator to Phobos, which orbits Mars at a relatively low altitude. This would eliminate the need for a counterweight, as Phobos itself could serve that purpose. A Martian space elevator could revolutionize the way we approach interplanetary travel, acting as a launch pad for missions deeper into the solar system. It could also facilitate the transport of resources and equipment between the Martian surface and orbit, supporting the development of a sustainable colony. The lower gravity on both the Moon and Mars not only simplifies construction, but also reduces the energy required to operate these elevators. On Earth, the sheer scale and energy demands of a space elevator make it a daunting prospect. But on these celestial bodies, the reduced gravitational pull means that climbers, the vehicles that travel up and down the elevator, could operate with far less power, making the entire system more efficient and sustainable. This efficiency could be a game changer for establishing permanent human presence on the Moon and Mars, as it would significantly lower the cost and complexity of moving goods and people between the surface and orbit. Of course, building space elevators on the Moon and Mars isn't without its challenges. For one, the lack of infrastructure in these environments means that construction would require advanced robotics and autonomous systems. Additionally, the materials used would need to withstand the harsh conditions of space, including extreme temperatures and radiation. However, the potential benefits far outweigh these hurdles. A lunar or Martian space elevator could serve as a cornerstone for future space economies, enabling the efficient movement of resources and fostering collaboration between Earth and its off-world colonies. As we look to the future, the concept of space elevators on the Moon and Mars represents a bold step toward making space exploration and colonization more practical and sustainable. It's a vision that combines cutting-edge engineering with the dream of expanding humanity's reach beyond Earth. And with that, let's turn our attention to another intriguing idea that could reshape our understanding of space: the controversial concept of space-based energy weapons and their potential implications for the future. Now, as we venture into a more contentious realm of space exploration, let's examine the concept of space-based energy weapons. This idea, often seen in science fiction, raises both fascinating possibilities and significant ethical concerns. Space-based energy weapons could harness the power of directed energy, such as lasers or particle beams, to defend against threats like asteroids or hostile spacecraft. Imagine a system capable of neutralizing an incoming asteroid on a collision course with Earth, potentially saving millions of lives. Such technology could also protect satellites and space infrastructure from debris or deliberate attacks, ensuring the safety of critical communication and navigation systems. However, the development of space-based energy weapons also opens a Pandora's box of ethical dilemmas. Weaponizing space could escalate tensions between nations, leading to an arms race in orbit. The very idea of placing weapons in space challenges international treaties, such as the Outer Space Treaty of 1967, which aims to preserve space for peaceful purposes. Critics argue that deploying energy weapons could destabilize global security, turning space into a new battlefield rather than a frontier for collaboration and discovery. The potential for misuse is significant, as these weapons could be repurposed to target Earth-based assets or even populations, raising profound moral questions. Proponents, on the other hand, highlight the defensive potential of such technology. Space-based energy weapons could act as a deterrent, preventing conflicts before they escalate. They could also provide a non-lethal means of disabling hostile satellites or spacecraft without creating dangerous debris fields. The key, they argue, lies in establishing robust international agreements and oversight to ensure these weapons are used responsibly and transparently. Striking this balance between innovation and regulation will be crucial as humanity continues to explore the possibilities of space. As we consider the implications of space-based energy weapons, it's clear that this concept sits at the intersection of technological advancement and ethical responsibility. The decisions we make today could shape the future of space exploration, determining whether it remains a realm of peaceful cooperation or becomes a new arena for conflict. With that in mind, let's shift our focus to another fascinating aspect of space exploration: the emerging field of space archaeology and how it could uncover the secrets of ancient civilizations, both on Earth and beyond. Now, let's turn our attention to a field that bridges the past and the future: space archaeology. This fascinating concept uses space-based technologies to uncover the secrets of ancient civilizations, both on Earth and potentially on other planets. Imagine using satellites orbiting hundreds of miles above the Earth to reveal hidden structures, lost cities, or even entire civilizations buried beneath layers of sand, water, or vegetation. These tools allow archaeologists to see what the naked eye cannot, mapping out ancient roads, settlements, and even patterns of human activity that have been lost to time. Satellites equipped with advanced imaging technologies such as LiDAR and multispectral imaging can penetrate dense forests or desert sands to reveal the outlines of ancient ruins. For example, these technologies have already uncovered hidden Mayan cities in Central America and ancient trade routes in the Middle East. By analyzing subtle changes in vegetation or soil composition, scientists can pinpoint areas of historical significance without ever setting foot on the ground. This not only accelerates the pace of discovery, but also preserves delicate sites from unnecessary disturbance. But space archaeology doesn't stop at Earth. As we explore other planets, particularly Mars, the same technologies could help us uncover evidence of past life or even ancient civilizations. Rovers equipped with ground-penetrating radar and high-resolution cameras could scan the Martian surface for signs of structures or artifacts buried beneath the dust. While the idea of finding extraterrestrial ruins may sound like science fiction, it's a possibility that drives the curiosity of scientists and enthusiasts alike. After all, if life once existed on Mars, could it have left behind traces of its presence waiting to be discovered? The implications of space archaeology are profound. On Earth, it helps us better understand our own history, revealing how ancient societies lived, thrived, and sometimes vanished. Beyond our planet, it could reshape our understanding of life in the universe, offering clues about whether we are alone or part of a larger cosmic story. As we continue to develop these technologies, the line between archaeology and space exploration blurs, opening up new frontiers for discovery. With this in mind, let's move forward to another groundbreaking concept: the idea of using space-based technologies to combat climate change on Earth, a topic that could redefine our relationship with our planet and beyond. Now, shifting our focus to a concept that could redefine our fight against climate change, let's explore the idea of space-based climate control. Imagine harnessing the vastness of space to protect our planet from the growing threats of global warming. This isn't science fiction, it's a bold, forward-thinking approach that could complement our efforts here on Earth. One of the most intriguing proposals is the concept of solar shields. These massive structures positioned in space would act like giant umbrellas, blocking a fraction of the sun's rays before they reach Earth. By reducing the amount of solar energy hitting our atmosphere, these shields could help cool the planet and counteract the effects of rising temperatures. While the idea sounds ambitious, scientists have already begun exploring designs, such as lightweight, reflective materials that could be deployed in orbit. The challenge lies in scaling up the technology and ensuring it's cost-effective, but the potential benefits are enormous. Another fascinating idea is the use of space mirrors. These mirrors, placed in strategic orbits, could reflect sunlight away from Earth or even redirect it to specific areas in need of warmth. For instance, they could help mitigate extreme weather events by balancing temperature disparities across the globe. While still in the conceptual stage, space mirrors represent a creative way to leverage space technology for environmental solutions. Of course, these ideas come with their own set of challenges. Building and deploying such large-scale structures in space would require unprecedented international cooperation and significant financial investment. There are also ethical considerations. How do we ensure these technologies don't have unintended consequences on Earth's ecosystems or weather patterns? Despite these hurdles, the potential to stabilize our climate makes space-based climate control a compelling area of research. As we continue to innovate, the line between Earth and space becomes increasingly blurred. These technologies remind us that the solutions to our planet's challenges might lie beyond its atmosphere. With that in mind, let's turn our attention to another mind-bending concept: the theoretical possibility of time travel and its implications for space exploration. Now, let's take a leap into one of the most fascinating and mind-bending ideas in science: the theoretical possibility of time travel. While it might sound like something straight out of a science fiction movie, the concept of time travel is deeply rooted in the principles of physics, particularly in our understanding of space-time. According to Einstein's theory of relativity, space and time are not separate entities but are interwoven into a single fabric known as space-time. This fabric can be warped, stretched, or even bent under extreme conditions, opening the door to some truly extraordinary possibilities. One of the most well-known theories supporting time travel involves the idea of wormholes, which we touched on earlier. These hypothetical tunnels through space-time could, in theory, connect two distant points in the universe, or even two different points in time. If we could create or find a stable wormhole, it might allow us to travel not just across vast distances but also backward or forward in time. However, the challenges are immense. Wormholes, if they exist, would require exotic matter with negative energy to remain open, and we're still far from understanding how to create or control such phenomena. Another intriguing concept is time dilation, a proven effect predicted by Einstein's theory of relativity. Time dilation occurs when an object moves at speeds close to the speed of light or is exposed to intense gravitational fields. For example, astronauts on the International Space Station experience time slightly slower than people on Earth due to their high orbital speed. While this effect is minimal in everyday life, it becomes more pronounced as you approach the speed of light. In theory, a spacecraft traveling near light speed could allow its passengers to experience time differently, effectively sending them into the future relative to those on Earth. But what about traveling to the past? This is where things get even more speculative. Some scientists have proposed the idea of closed time-like curves, which are paths through space-time that loop back on themselves, potentially allowing an object or person to return to their own past. While these curves are mathematically possible under certain conditions, they remain purely theoretical and would require conditions that are far beyond our current technological capabilities. The implications of time travel for space exploration are profound. Imagine being able to observe distant galaxies as they were billions of years ago, or witnessing the formation of our solar system firsthand. Time travel could also revolutionize our understanding of the universe, allowing us to test theories and gather data in ways that are currently impossible. However, it also raises significant ethical and philosophical questions. What happens if we alter the past? Could we create paradoxes that disrupt the fabric of reality? While time travel remains a tantalizing possibility, it's important to remember that we're still in the realm of theory. The scientific community continues to explore these ideas, pushing the boundaries of our understanding of space-time. As we venture further into the cosmos, who knows what discoveries await us? Perhaps one day, the mysteries of time travel will no longer be confined to the pages of science fiction, but will become a reality that reshapes our future. With that thought, let's move on to another captivating concept: how space exploration could inspire entirely new forms of art and culture. As we ponder the mysteries of time travel, let's shift our gaze to something equally profound yet deeply human: the role of art and culture in the vast expanse of space. Space exploration isn't just about science and technology. It's also a canvas for creativity, offering endless inspiration for new forms of expression. Imagine the stories, music, and visual art that could emerge from humanity's journey beyond Earth. The cosmos, with its infinite beauty and mystery, has always sparked the imagination, and as we venture further into the stars, it's likely to give rise to entirely new cultural movements. One of the most exciting possibilities is the creation of art that reflects the unique experiences of life in space. Picture a painting that captures the surreal beauty of a sunrise seen from orbit, where the Earth's curvature glows with vibrant hues. Or consider music composed in zero gravity, where the absence of weight could inspire entirely new rhythms and sounds. Artists living and working in space might develop techniques and styles that are impossible to replicate on Earth, giving birth to a whole new artistic genre. But it's not just about individual creativity. Space exploration could also foster a shared cultural identity among humanity. As we establish colonies on the Moon, Mars, and beyond, these new societies will likely develop their own traditions, stories, and symbols. Over time, these could blend with Earth's diverse cultures, creating a rich tapestry of interplanetary heritage. Think of festivals celebrating the first lunar landing or Martian art exhibitions showcasing the unique landscapes of the Red Planet. These cultural expressions could unite people across planets, reminding us of our shared humanity even as we spread across the stars. Moreover, art and culture could play a crucial role in shaping our future in space. Creativity has always been a driving force behind innovation, and the challenges of space exploration will require imaginative solutions. Artists, writers, and thinkers could help us envision what life might look like in space, inspiring scientists and engineers to turn those visions into reality. They could also address the ethical and philosophical questions that arise as we expand into the cosmos, helping us navigate the complexities of interplanetary life. Consider, for example, how space-based art could influence our understanding of our place in the universe. A sculpture floating in zero gravity might evoke a sense of wonder and humility, reminding us of the vastness of space and the fragility of our planet. A novel set on a distant exoplanet could explore themes of identity, belonging, and the human condition in ways that resonate deeply with readers. These creative works could help us process the profound changes that come with becoming a spacefaring civilization. As we look to the stars, it's clear that art and culture will be as essential to our journey as rockets and rovers. They will help us make sense of the unknown, celebrate our achievements, and connect us across the vast distances of space. So, while we marvel at the technological wonders of space exploration, let's not forget the power of creativity to shape our future. And with that, let's turn our attention to another fascinating frontier: the advancements in medical research made possible by life in space. Now, let's take a closer look at how space exploration is revolutionizing the field of medicine. The unique environment of space offers scientists and researchers opportunities to conduct experiments that simply aren't possible on Earth, leading to groundbreaking discoveries that could transform healthcare for everyone. One of the most fascinating areas of study is how the human body behaves in zero gravity. Without the constant pull of Earth's gravity, our bodies undergo significant changes, from muscle atrophy to shifts in fluid distribution. These changes provide valuable insights into how our bodies function, helping researchers develop new treatments and therapies. For example, studies conducted on the International Space Station have revealed how microgravity affects bone density. Astronauts in space experience bone loss at a much faster rate than people on Earth, similar to conditions like osteoporosis. By studying these changes, scientists are gaining a better understanding of how to prevent and treat bone-related diseases. This research has already led to the development of new drugs and therapies that could help millions of people suffering from osteoporosis and other bone disorders. Another exciting area of space-based medical research is the study of protein crystals. In the absence of gravity, proteins can form larger, more perfect crystals than they do on Earth. These high-quality crystals allow scientists to analyze their structures in greater detail, which is crucial for developing new medications. For instance, research conducted in space has contributed to advancements in cancer treatments, as well as therapies for conditions like Duchenne muscular dystrophy and Parkinson's disease. The ability to grow these crystals in space could accelerate the development of life-saving drugs and improve their effectiveness. Space exploration is also shedding light on the effects of long-term space travel on the human body, which has direct applications for future missions to Mars and beyond. For instance, researchers are studying how prolonged exposure to microgravity impacts the cardiovascular system, vision, and even the immune system. These findings are not only essential for keeping astronauts healthy during long missions, but also have implications for improving healthcare on Earth. Understanding how the body adapts to extreme environments can help doctors develop better treatments for patients dealing with similar challenges, such as those recovering from prolonged bed rest or undergoing rehabilitation. Moreover, the technology developed for space medicine is finding its way into everyday healthcare. Devices originally designed to monitor astronauts' health in space are now being used in hospitals and clinics. For example, portable ultrasound machines, initially created for use on the International Space Station, are now helping doctors in remote areas provide critical care to patients. Similarly, advancements in telemedicine, which allows doctors to monitor and treat patients from a distance, were pioneered in space and are now transforming healthcare delivery worldwide. As we continue to explore the cosmos, the medical breakthroughs made in space will undoubtedly have a profound impact on life here on Earth. From improving our understanding of the human body to developing cutting-edge treatments, space-based medicine is opening up new frontiers in healthcare. And with that, let's turn our attention to another exciting concept: the potential for space-based education to inspire and prepare the next generation of explorers. Now, shifting our focus to the stars and beyond, let's explore how space exploration is not just about scientific discovery, but also about inspiring and educating the next generation. Space-based education is a concept that holds immense potential to ignite curiosity and passion in young minds, preparing them for the challenges and opportunities of the future. Imagine a classroom where students don't just read about the cosmos, but experience it firsthand through immersive technologies and real-time interactions with astronauts and scientists. This is the promise of space-based education. One of the most exciting aspects of this concept is the use of virtual reality to bring space exploration into the classroom. Virtual reality allows students to step into the shoes of an astronaut, explore the International Space Station, or even walk on the surface of Mars, all from the safety of their school. This immersive experience not only makes learning more engaging, but also helps students grasp complex scientific concepts in a way that textbooks simply can't. For example, instead of just reading about the challenges of living in microgravity, students can virtually experience it, gaining a deeper understanding of how space affects the human body and daily life. Beyond virtual reality, space-based education also includes programs that connect students directly with space missions. Initiatives like NASA, a STEM on station, allow students to design experiments that are conducted by astronauts in space. These hands-on projects give students a unique opportunity to contribute to real scientific research, fostering a sense of accomplishment and inspiring them to pursue careers in science, technology, engineering, and mathematics. Imagine the thrill of seeing an experiment you designed being carried out hundreds of miles above Earth. Moreover, space exploration has the power to inspire a sense of global unity and curiosity. When students learn about the vastness of the universe and the challenges of exploring it, they begin to see themselves as part of something much larger than their immediate surroundings. This perspective can encourage collaboration, innovation, and a shared sense of purpose, qualities that are essential for solving the complex problems facing our world today. As we look to the future, space-based education could also play a crucial role in preparing humanity for long-term space exploration and colonization. By teaching students about the technologies, challenges, and ethical considerations of living beyond Earth, we're equipping them with the knowledge and skills needed to become the next generation of explorers, engineers, and scientists. And with that, let's turn our attention to the ultimate goal of space exploration, the search for extraterrestrial life. Now, as we reach the final frontier of our journey through these mind-blowing concepts, we arrive at the ultimate question that has captivated humanity for centuries: are we alone in the universe? The search for extraterrestrial life is not just a scientific endeavor, it's a quest that touches the very core of our curiosity and imagination. This pursuit drives some of the most ambitious missions in space exploration, pushing the boundaries of what we know and what we hope to discover. One of the primary methods scientists use to search for extraterrestrial life is the study of exoplanets, planets that orbit stars outside our solar system. With advancements in telescopes like the James Webb Space Telescope, astronomers can now analyze the atmospheres of these distant worlds, looking for signs of habitability. For instance, the presence of water vapor, oxygen, or methane in an exoplanet's atmosphere could hint at the possibility of life. Imagine the excitement of finding a planet with conditions similar to Earth, where life as we know it could thrive. But the search doesn't stop at distant stars. Closer to home, icy moons like Europa and Enceladus have become prime targets in the hunt for extraterrestrial life. These moons, orbiting Jupiter and Saturn respectively, are believed to harbor vast oceans beneath their frozen surfaces. Missions like NASA Europa Clipper aim to study these oceans, searching for signs of microbial life. The idea that life could exist in the dark, icy depths of these moons challenges our understanding of where life can thrive and opens up thrilling possibilities. Another fascinating approach is the search for biosignatures, chemical or physical markers that indicate the presence of life. Scientists are developing advanced instruments to detect these signatures, whether in the soil of Mars, the plumes of Enceladus, or the atmospheres of exoplanets. Each discovery, no matter how small, brings us closer to answering the profound question of whether life exists beyond Earth. Beyond the scientific methods, the search for extraterrestrial life also inspires us to think about our place in the cosmos. What would it mean to find life elsewhere? How would it change our understanding of biology, philosophy, and even our own identity? These questions remind us that space exploration is not just about technology and discovery, it's about expanding our perspective and redefining what it means to be human. As we conclude this exploration of 30 mind-blowing concepts in space exploration, it's clear that the search for extraterrestrial life is more than a scientific mission. It's a journey that unites us in wonder, curiosity, and the shared hope of discovering that we are not alone in the universe. And with that, we wrap up our journey through the stars, leaving you with a sense of awe and a call to keep looking up, because the universe still holds countless mysteries waiting to be uncovered. As we bring this journey through 30 mind-blowing concepts in space exploration to a close, it's impossible not to feel a sense of awe at how far we've come and how much further we have yet to go. From the dream of interstellar travel to the possibility of finding extraterrestrial life, each concept we've explored represents a bold step toward redefining humanity's place in the cosmos. These ideas aren't just science fiction, they're blueprints for a future where the boundaries of our world extend far beyond Earth. Think about it, space elevators could revolutionize how we access orbit, making space travel more affordable and sustainable. Terraforming Mars could give us a second home, ensuring the survival of our species. Dyson spheres and space-based solar power could provide limitless energy, solving one of humanity's greatest challenges. And the search for extraterrestrial life could answer the most profound question of all: are we alone? Each of these concepts has the potential to reshape our future in ways we can barely imagine. But this isn't just about technology or discovery. It's about what these ideas mean for us as a species. They challenge us to think bigger, to dream beyond the confines of our planet, and to work together toward a shared vision of the future. Space exploration reminds us that we are part of something much larger, a universe filled with endless possibilities. So, what's next? The future of space exploration depends on all of us. Whether you're a scientist, an engineer, an artist, or simply someone who looks up at the stars and wonders, you have a role to play. Stay curious, support space exploration efforts. Share your passion with others, because the more we invest in these ideas, the closer we get to turning them into reality. Thank you for joining us on this incredible journey through the cosmos. If you enjoyed this video, don't forget to hit the like button, subscribe to our channel, and ring that notification bell so you never miss out on the latest updates from the world of space exploration. Together, let's keep reaching for the stars, because the universe is waiting and the best is yet to come.